Good afternoon, everyone. Thank you for joining us for our Introduction to HVAC and Building Tune-Ups for Energy Savings webinar. I'm glad you were able to log on. I know some of you are having lunch. My name is Lorena, and I'll be co-hosting today's webinar. And I will be monitoring chat and some of the pollings throughout the session. As you see one to the right of the screen, feel free to go ahead and submit your answers to there as we do our introduction here. We hope that after today you'll be able to understand some of the fundamentals and be able to apply them at your facility to help you save energy and money. We also want to thank our sponsors, Energy Trust of Oregon and Northwest Energy Efficiency Alliance. Based on our customer feedback, they really appreciate that we work together with them to help eliminate any confusion regarding energy efficiency and renewable messages that we provide to everyone. Before I introduce the presenter, I wanted to show you some of the tools that we're using throughout the webinar. Again, we want to make it interactive, and we want it to be helpful for you. So please do engage as we go through the presentation. You'll see under the participants window where all your names are listed, all the way at the bottom of that, you'll see a little raise hand icon. You feel free to use that button if you have any questions or you have a comment you'd like to share, and then we'll unmute your phone. Right underneath that is a chat window where you can send me any questions. We'll address them throughout the session as best as we can, but we do have some time dedicated at the end to address them. You'll also see, again, the polling. There's another one that's going to come up at the end of the session for your feedback. On the top left corner of your screen, where I'm highlighting right above that, you'll see the arrow, the T, there's a pointer, there's a marker, an eraser. Those are the tools that you'll be using throughout the session, and the instructor will let you know when to use those. And we'll go ahead, and again, we want to make it interactive, so feel free to submit questions, thoughts, or if you run into any issues, I'll be handling that for you. Now I'll go ahead and introduce Greg Nelson. He's a commercial industrial energy engineer at Portland General Electric. He has over 16 years of experience in commercial and industrial system design and operation. His focus is finding energy saving opportunities within your businesses and then making recommendations on what they've identified for opportunities for efficiency improvements, and also those that qualify for the Energy Trust of Oregon incentives and other incentives and tax credits that may be available throughout the year. He is also an Oregon professional engineer since 2001 and a certified energy manager since 2011. So Greg, we'll go ahead and have you get started here.
Thank you very much, Lorena. And so while we're waiting for the polling results, let me just give you some additional background. Yeah, when I first moved up here after college, I started work as a consulting engineer in the Portland area and designed HVAC and some plumbing systems, dabbled a little bit in lighting. And then for the past 10 years, though, I've been working for PGE as an engineer promoting energy efficiency, as Lorena said, for commercial and industrial customers. We got the results. We got some engineers and consultants and then a property manager out there. And Lorena, it looks like the population of attendees is relatively low, so I'd be more open to answering questions on the fly as they pop up. But again, we may not be able to address all your questions right when you ask them, but there should be some time at the end of the presentation to cover them. This course is going to cover some basic topics, which are shown here on the slide. But I wanted to give you a quick rundown. This webinar and the associated seminar are designed for our customers to help them learn more about both tune-ups and commissioning opportunities. And as a result, this webinar definitely is more of a high-level description and is going to touch on some subjects, but it's not going to delve into a bunch of detail. And with some engineers and consultants out there in the audience, some of you may be able to present this material that I'm presenting today, and so please just keep that in mind and feel free to ask questions that are pertinent to you, anyone out there in the audience. So the background we're going to cover today, some just basic topics to get everybody grounded and make sure we're all talking apples and oranges in the right order. And then moving on from background, we'll talk about some benchmarking opportunities for customers to take a look at their energy consumption and see how they compare to other folks out there. Moving on from there, we'll talk about basic tune-ups, and then we'll close out again with the question and answer session at the end. So background. Wanted to touch on some main terminology that we're going to be using today. Kilowatts is a measure of electric power. Oftentimes it's an instantaneous reading. If you see kW on your utility bill, however, though, it's the average highest 30-minute kW demand that you've seen for that month. And I should take a step back and say that most of the comments I'm going to have today, most of the specifics I'm going to delve into are going to be purely focused on for the most part, PGE customers and Northwest customers in general. Your mileage may vary, your rates may be different in other jurisdictions. Moving on from kW, we've got kWh. So let's take the instance where we've got a 100-watt light bulb. If we turn that light bulb on, it's going to require 100 watts of power. If we have 10 of those light bulbs on, it's going to require 10 times 100, or 1,000 watts. So essentially a kilowatt of power. If we leave those 10 light bulbs on for 1 hour, we will have consumed 1 kilowatt hour of energy consumption. Then moving on down the list to therms, we've got therms, and that's a measurement of natural gas energy consumption. You'll see that on your natural gas bill if you have one. And then finally, BTUs, British Thermal Units. This is a relatively small quantity, and it's often used to describe energy consumption from multiple fuel sources. A lot of buildings out there have electric service and natural gas service, and so the BTU term allows you to group all those fuel sources together and start talking across the board. What does a typical office use? Now, the next topic is, why would you want to tune up a new building? It's a new building with new equipment. I mean, it should function just perfectly, shouldn't it? But I want to take a step back and talk about the process of designing and constructing a new building. So typically, a building owner is going to work with an architect. They'll have some conversations around the goals for the building. How many square feet, how many people do you need to house in the building? What are the hours of operation? What sort of egress requirements are going to be required by code? Those are the issues that the architect is going to have to begin to work with. And there'll be multiple conversations between the architect and the building owner. But then ultimately, in order to get the design down on paper, the architect is going to work with an engineer to then interpret how that owner's vision of the building is going to need to be heated and cooled and lighted, and how the structure is going to need to be maintained and meet the needs for the building owner. There can often be some conversation between the building owner and the engineers, but the engineers may also just be a subconsultant of the architect. So after the design process is done, the design is now on paper, the engineer is comfortable with the size of the chillers or the packaged rooftop units or the lighting systems that are being specified. That's when the architect and possibly the building owner or one or the other is going to have a contractor bid on the construction of that design. How is that design ultimately going to be brought into the physical world? And as you can see, there's multiple lines of communications, and even during the design process, the contractor and engineer may have verbal communication, or at least probably more often than not, they have at least nonverbal emails or contract requirements, reviewing submittals and things of that nature. There's lots of lines of communication. And then even once the building is built and in operation, the building operator has to then make that physical building work for the occupants that have moved into it. They've got to set the temperature set points. They've got to decide when to turn on lights in the building and things of that nature. So again, lots of lines of communication, and anytime you have lines of communication, there's chances that that communication is not going to be interpreted exactly right. And anytime you have that lack of clarity, that means it's an opportunity for something to go wrong or not perform optimally. And that's why you may want to tune up or commission a new building. So why tune up an older building? a lot of the same scenarios are going to come into play here. Your building owner may have owned the building for 10 years. It's a 10-year-old building, but tenants move out. And so the building owner may work with a contractor to change the layout of a space or multiple spaces within the building, or maybe the whole building, to meet the needs of the new tenants. And that contractor may need to work with an engineer to make sure that all the code compliance is happening correctly and all the systems are going to be modified to meet the new needs of the new customer. And sometimes the engineer has direct line of conversations with the building owner, sometimes they don't. But again, now we've got a building operator that has to adapt to new tenants in the building, and so changes have to occur in the control strategies. That building operator may or may not be that same building operator that moved into the building 10 years ago, and the current building operator may be interpreting the operation of the best operation of the building in a different way than the original design intended. And so again, whenever we have lots of lines of communication, there's an opportunity for things to go wrong or to not move in an optimal manner. So here's the first opportunity I'm going to give you to provide some input and help me guide the rest of the presentation. If you look at the top of your screen, we've got a tool here that you can use. Right above that blue dot that I put on there is a magic marker. You can also use an arrow here. The arrow is going to allow you to put an arrow indicating what type of facility you are most interested in. So I want to give everyone a moment to put some input in there. We've got office space and we've got other so far. But, looks like there's some manufacturing out there. I'm just going to take a few more seconds to let additional people provide input, but then we'll move on. Okay, I think that's fair enough for now. Hopefully some more of you get a chance to use some of the tools in the later part of the presentation. So we've got offices, manufacturing, and other. Here's an energy use profile for an office, a typical or probably more apt, an average office in the Pacific Northwest. We can see that heating is a relatively large energy consumer in the building, and so is ventilation and space cooling. I'm going to switch colors to yellow now just to make it a little bit more clear. And then we've got lighting as well. So the usual suspects here for an office building, large energy consumers, are your HVAC systems, your heating, ventilating, and air conditioning, but then also lighting. And keep in mind that this is kind of the average office building, so you may not be an average office building. You may be in a building where you have a lot of computers, and maybe your computer load is higher than just 6%. Or, any number of iterations are out there. Moving on to a hospital. I don't have a pie chart for manufacturing, but some manufacturing spaces would perform similarly to a hospital. Hospitals have a lot of outside air, and therefore they have a lot of heating requirements, and then we still have the AC and ventilation going on. But now we've got water heating because we've got a lot of water use and sanitation required in the hospital. But again, lighting is still a big component there too. So knowing the facility you're in and where energy is being consumed can help you target your benchmarking or your tune-up and your commissioning efforts. Moving on, this is the last pie chart I have in this section. It just demonstrates that industrial customers can be all over the board. The biggest energy consumer typically in an industrial environment is shockingly enough, the equipment that is used to produce a product or to refrigerate a product. And just because this chart may not be very useful, in a numbers standpoint, I definitely see this useful because if you are an industrial customer, you need to concentrate on, number one, getting your product out the door in an effective manner. But if you are going to look at energy efficiency, take a look at your process rather than your office space. You know, most industrial operations have minimal office load, um, but again, your mileage may vary. Now that we've grounded ourselves with some of the background, I want to move into the benchmarking topic. In order to benchmark, you need to know how much energy you are consuming. And one method of doing that is to log your monthly energy consumption. And so down here we've got a school in the Portland metro area that has taken their electric utility bills and put them in a table. We've got data from 3 years ago, 2 years ago, and then the most recent year here demonstrated. What this allows you to do is to see what's changing over time. In this case, this customer 3 years ago is, and 2 years ago, they're seeing a steady increase in energy consumption. Their most recent year is quite a bit higher than their previous 2 years average consumption. And you know, maybe that makes sense. Maybe the school has doubled their classroom sizes. They've added a wing onto the building, or they've added portables, or what have you. But in the case of a customer who has this type of steady increase of energy consumption, maybe they can't identify a change that's gone on, or they can't comfortably say that, yes, this energy consumption increase makes sense for me because of X, Y, and Z. Maybe they have this increase and they haven't made no major changes to their processes. So that would indicate to me that this would be a prime candidate for some tune-up and or commissioning opportunities. But who has time for that? You know, if you're like me, you've got a lot of stuff on your plate. You've got to prioritize things. And so I wanted to offer you a quick alternative to logging your monthly energy consumption. Not that logging your monthly energy consumption is a bad thing, but if you don't have the time, here's another alternative. To get a quick idea for your annual energy use, most utility bills are going to have a graph that looks like this. And whether it's your electricity consumption or your natural gas consumption, the bill that you get for your meter should have a graph like this on it. And you can often get a graph like this on maybe your water bill too. So it's not just energy that you can track this way, but it's basically utilities in general that you can track. So if you draw a line where you feel like your average consumption is, I should step back and say that this graph is 13 months worth of utility consumption for this meter. And so I've drawn a line here at what I call the rough average daily energy consumption. And so we're at 8,100. With some quick math, we can say that 8,100 times 365 days a year would give us 2.9 million kilowatt hours of energy consumption. And just to kind of ground you, I know this seems like a really crude method to estimate your annual energy use, but what do you want? It's quick. But really, I went back and I looked at this particular customer, and even using this relatively high average of 8,100, you know, it looks like maybe the average is closer to 8,000. But even using this high average number, I was able to get within 3% of the annual energy consumption of this facility. So it's quick. It is dirty, but it's quick. Now what can we do with that? We can't benchmark until we know what our facility is doing. So we've done that. We know what our facility is consuming in electricity and natural gas if we have it, or other utilities if we have them. Now we can compare ourselves to other people, basically our peer group. And one opportunity is to look at regional data. And one of our co-sponsors, the Northwest Energy Efficiency Alliance, does periodic surveys of the Northwest to get information about energy use in the area. They ask customers about their occupancy type. You know, are they an office? Are they a retail space? Where are they located? What's their floor area? And what type of building systems they have. You know, they don't just ask 4 questions, but those are the categories of questions, the real meat of the survey. Another source to look at is the Energy Information Administration. They publish data regularly for locations across the United States. And so here we are in Oregon. Unfortunately for us, while this data has a lot of points and has a lot of useful information, unfortunately the weather associated with the group of occupancies or the locations that we're grouped with, we're grouped over here in the Pacific West, and we're in there with Washington, California, Alaska, and Hawaii. And I don't know about you, but I'd rather be in Hawaii in the wintertime than Alaska. There's a huge difference in the weather conditions in this region that we're grouped into. And so you can't just take this information. You've got to take this information and think about, okay, how does a facility in Oregon differ from its neighbors? And that's mainly going to be weather, but it's also going to be related to what are the energy code requirements of the area that you're looking at. So rather than having you do all that research yourself, we've kind of taken the numbers and squashed them together. So we've combined the NEIA and EIA results here. And so here's that BTU term that I talked about earlier. We've got a wide range of mainly commercial type occupancies, and commercial is predominant on this list because commercial is relatively predictable. I mean, an office building is going to have typically 8 hours a day of true hard work going on. Maybe if you're like me, you're spending a little bit more time in the office too. But you know, the space temperatures are going to be pretty typical. But you know, if you then try to look at a refrigerated storage warehouse, you know, a non-commercial type occupancy, it's going to depend on what type of refrigerated storage you're doing to then determine what your benchmark of energy consumption should be. You know, if you've got real cold temperatures you're trying to maintain, then you're going to consume more energy than if you're trying to maintain warmer temperature. Enough said on that. So in the column here, we've got kBTU per square foot per year. This is the total fuel consumption at the site. And I don't know about you, but when I look at a utility bill, I never see it billed in kBTUs or BTUs. It's always in kWh or you know, therms of natural gas, or maybe it's propane, you know, monthly fill-ups. You know, taking a look at so now if we consider, okay, what type of facility am I? What type of fuel use do I have? If I have all electric service in my building, I'm using electricity for heating, and therefore I may be consuming more energy than a building, more electricity anyway, than a building that is heated with natural gas. Looking at that type of building, for example, if it's an education facility, and I should step back and say that in this case, this chart represents education facilities that are K through 12 and higher education. If you are dealing with a grade school, for example, maybe a elementary school, you might expect your total energy consumption to be in the range of about 50 kBTU rather than the 76.8 kBTU per square foot per year. But now you got to look at this and see, you know, compare yourself to these numbers based on the type of fuel you are using. Moving on, I'm going to show you how to use this information. So let's take the example of an office building. And they've done their research. They know they're consuming 120,000 kilowatt hours per square foot per year. I'm sorry, 120,000 kilowatt hours. I'm getting ahead of myself. And they know they're just over 6,000 square feet in occupiable space. So you do the math. You take the energy consumption, divide it by the square footage. You come up with 19.3 kWh per square foot per year. So the question I have for you, and this is another opportunity for you to chime in, and I would definitely recommend, you know, using the text tool here at the top. The question I have for you, you know, is this good or bad? And I'll take a few seconds to let you input your answers. So we got a good there so far. I want to try to get a couple more inputs and bad. And good. Okay. And you know, you're all right and you're all wrong. Um, it really depends, and it could be good for you and it could be bad for you. So let's go into details as to why I said that, and then I kind of said that in a rude manner, but you get the point. An office building. So if I'm consuming 19.3 kilowatt hours per square foot per year, and I'm heated with electric, you know, maybe I have electric resistance heating, or maybe I have electric reheat coils, whatever. If I don't consume natural gas, if I don't have a natural gas meter, then I can look at this number. So I'm 19.3 compared to 24.4. I'm doing better than average. But let's say this building that we're talking about is a natural gas heated building. We would then expect, you know, the heat would be mainly coming from natural gas. Therefore, the average building should consume less. So we're at 19.6. So in this case, this 19.3 is higher than 16. It could be bad, but even beyond that, it comes down to what are your goals and what truly type of facility are you? Are you truly a typical office space, or do you have server rooms, or are you a call center with long hours of operation? And then above and beyond that, you know, what are your goals? Do you strive to be better than average, or are you more focused on and do not have time to or money to invest in energy efficiency that can help you improve your performance? There is no right answer to this, basically, and that's probably a better way of saying that. Benchmarking. So this next series of slides is going to give you some tools, some more in-depth tools to use to give you a more involved, but probably, you know, more robust benchmarking of your facility. You know, I showed you earlier the quick and dirty method of estimating energy consumption and then benchmarking yourself against the combined IEA and EIA and NEA information. If that's not robust enough for you, another tool you can use is the Energy Star Portfolio Manager. And that allows you to benchmark yourself against some common, again, commercial type facilities. We've got banks, we've got data centers, we've got K through 12 schools, offices, things of that nature. And again, they're commercial because those tend to have more typical types of operation going on when you compare commercial to industrial. Industrial is all over the board. So in order to get to the benchmarking tool, you go to the website, www.energystar.gov, and then you click on Buildings and Plants. From there, you'll come to a sheet, a website that looks like this. And here you have two options. You've got Portfolio Manager, or you've got Target Finder. And it comes down to what are your goals. If all you want to do is do a relatively quick benchmarking, then Target Finder's probably the tool for you. If you know that you're going to be logging or benchmarking yourself multiple times over the course of the year and coming years, then maybe Portfolio Manager is the better tool for you. Portfolio Manager allows you to put more information in and give you a more robust benchmarking result. Regardless of the tool, the website will then ask you some basic information about your facility. You know, where are you located? Exactly how is your office or warehouse broken up. In this case, we've got an office building, but that's a small component of the total facility. This facility is really a refrigerated warehouse, and they've got some unrefrigerated storage space as well. Total square feet of 160,000, just to give you some context there. It'll ask you what your fuel energy consumption is, your electricity and your natural gas and any other fuel sources that you have. It has some opportunities to, again, enter propane or other fuel sources. And then with each type of occupancy within your facility, it's going to ask you some additional details. What are your hours of operation? How many people do you have on the main shift? And so here we've got a typical office schedule, and then, of course, the refrigerated space is operating 24/7. It'll ask you the number of computers in the space and how much is cooled and how much is heated. That's the input section, and the layout of the input is a little bit different. It asks you these questions in a different manner, but these are basically the inputs that you're going to be required to give. With that, you can spit out the results. This is an example of the results that you get from Target Finder if you would have input those values that I just showed you. The design is your current scenario. Your current square footage, your current operation, your current energy consumption. How does that look? And in this case, the facility got a score of 70. And that means that the facility is 70% better than the rest of the nation for a typical for that same type of occupancy and operation. From there, you can set a target. You can say, well, I'm not happy with 70, I want to go to 80. And so that then begins to give you an idea for how much energy consumption do you need to reduce in order to improve your performance from being better than 70% to being better than 80%. That's just a quick example of the tools. I encourage you to try them out if you got the time. And even if you are a non-commercial facility and or you don't see your type of facility on the list of facilities that they've got benchmarking information for, there is still some useful information on the Energy Star website. They've got general industrial information. There's some performance indicators, which is a type of benchmarking technique that can be used for industrial customers. It talks about, how much energy should be used per pound of product being produced and things of that nature. So industrial facilities are a little bit tougher to benchmark because you got to know more details, and every customer is unique, but there still are some techniques that can be used, and I encourage you to check out the website. There's also information on technologies that we commonly find in industrial applications, compressed air, process heating, and pumping, and the like. But if you don't see information on here that is going to be helpful to you and you would like some additional information, feel free to shoot us an email. The Energy Trust of Oregon is a great service to customers in our area to provide information and to provide incentives to improve energy efficiency as well. So here's another opportunity for you to provide some input. Just kind of check the box that applies most closely to you, and feel free to check multiple boxes. This is going to help me as we delve into benchmarking opportunities as to what type of mechanical systems, for example, you might have in your building. So we got 1 and 2 floors, more than 10,000 square feet. So again, we can see that there's a wide variety of people listening in, and they have, you all have probably a wide variety of equipment that you're dealing with, and this presentation, this webinar today is mainly going to just cover the surface. And if you want more details, I would encourage you to come to the seminar that's coming up. So that's good enough. Again, we're all over the board. A office building that's 1 to 2 floors is typically going to have packaged rooftop equipment or split systems, and I'll go into a little bit more detail on that in a little bit. Whereas a larger facility may have variable air volume systems and other, what I would call more complex HVAC and lighting scenarios. Thank you. So when you look at commissioning, you have different levels of commissioning. You can start on one end as your basic tune-up, and then on the other end you have full-blown commissioning. And typically, basic tune-up is something that could be performed by a customer, and typically full-blown commissioning is something that you would want to contract out. But you can be anywhere along the range on this ruler that I have shown here, and maybe you're a customer who's very comfortable delving into the mechanics and the controls of your equipment that you're operating, and therefore there may be some commissioning type tasks that you can implement that you don't need a third party for. But if you are talking about doing a extensive commissioning of like a multiple story building, I would strongly urge you to bring in a third party to help you look at optimizing your systems, because just by the nature of the systems and nature of the day-to-day operation, you may not be able to see everything that an outside person looking in is going to be able to catch and help you with. Here are some basic lighting tune-ups. So as you may recall from before, regardless of the type of facility you have, lighting is often a good thing to look at for optimizing not only the efficiency of, using incentives to upgrade older lighting technology is always a good thing to consider, but you should also think about how am I operating my current lighting systems. And in that arena, we've got occupancy sensors. There's a lot of these out there in the marketplace, and some perform better than others, and some of the reasons why some of the equipment isn't performing properly is because the systems haven't been adjusted properly. Many occupancy sensors, shown over here as an example, have this ability to change not only the timing, but where the sensor is looking. And so I don't know about you, but I've been in plenty of conference rooms where the lights turn off when the conference room's full, or the lights turn on when nobody's in the conference room because somebody walked by and the occupancy sensor caught their motion in the corridor and turned on the light. So basically, you often have opportunities to adjust where the sensor is looking, and then you can adjust the timing to make sure lights are not turning on when you don't want them, and they're not turning off when you need them on. And use the correct type. There's lots of different technologies out there. Some are going to listen for sound rather than look for motion. Others are going to look for motion and not be able to listen for sound. And then you've got some dual technology out there where it does both. And those can be more robust. Of course, they're more expensive too. So you just have to keep that in mind, that there are technologies out there, and make sure that you're using the correct technology for your application. Next on the list is time clocks. And here's an example of an older style time clock. And just because maybe you have this older style in your facility doesn't mean you need to rip it out and put in a new fancy astronomical clock, but it can be an opportunity for you. If you have these older systems, the key is to look at where these pins are placed. These pins are rotating around on this timer, and depending on the pin location is going to tell the system to turn on or off lights. And you can have a timer like this on a pump system too. So regardless of what the timer is on, check it periodically to make sure it makes sense, the operation makes sense, and the pins haven't fallen out. If it is on a lighting system, you need to periodically check it to make sure your lights are coming on appropriate for the season that you're in. You've got long hours of daylight in the summertime and short hours of daylight in the wintertime, and so it's not uncommon to have customers adjust these timers 4 times a year or even more to truly hone in on the best operation for them. The best operation being least energy consumption while still maintaining adequate light levels. Replace failed occupancy sensor or photo sensors. And this can be pretty obvious if you roll up on a commercial site and at 2 in the afternoon and all the exterior lights are on. That usual suspect is, maybe there's a failed photo sensor or a dirty photo sensor out there thinking that it's nighttime when it's really daylight out there. And, depending on your facility, this may or may not be a huge energy consumer in the grand scheme of things. It may not, if you have got 4 outdoor lights and they're on during the daytime, it's not going to show up on your bill or it's not going to show up on your bill dramatically if you've got other bigger users in your facility. Sweep controls, I'm not going to go too deeply into those right now, but basically sweep controls are often found in larger facilities. They allow the operator to periodically shut off lights during periods of typical non-occupancy. So in the case of the building I'm in, for example, the lights will sweep off at about 8 o'clock, I believe, and um, the system gives occupants a chance to override the sweep controls. So, for example, I've been here later than that 8 o'clock time frame before, and I've been able to turn the lights back on. But a good sweep control system will have the ability to sweep off not just once a night, but multiple times in the night, because maybe I'm not going to remember to turn off the lights once I leave after 8 o'clock, and the sweep controls could then sweep off again at 9 o'clock and 10 o'clock and truly optimize the control of your system. And then finally, zoning. Whenever you're working with, especially an older facility, occupant needs change over time. Walls have to move sometimes to fit new requirements. And so when you move a wall, make sure you move the wall switch that is controlling the lights in the area. The last thing you want to do is have a light switch in a closet that's controlling most of the facility. If it's out of sight, it's going to be out of mind, and lights are going to be left on more often than they're needed to be on. And then consider a maintenance plan for your lighting system. If you're up there changing the light bulb, maybe you need to, or the lamp, you need to clean the fixtures. A clean fixture is going to be able to put out more light typically than a dirty fixture is. And then think about what is the life expectancy of my fixture. If you've got T12 fluorescent lighting out there, I definitely would recommend you change it out to T8 or some other technology. And even if you've got some older T8s, maybe 10 years old, start thinking about some newer, more efficient T8s or other technology options that are out there and controls to help you optimize your energy use. HID fixtures are typically found in areas with high ceilings like storage bays, maybe big box retail stores. They're typically the round fixtures, and most HID lighting can effectively be replaced with fluorescent, and you can see some substantial energy savings, and there's typically some good incentives too. Moving on from lighting, I want to talk about some basic HVAC tune-ups. And so this is a picture here of a couple of rooftop units. There's one that I circled, and in this case, it's a natural gas heated system. And this is the type of system that you would perform basic tune-ups on. And this packed rooftop and maybe a split system air conditioner and split system heat pump, those are the things that we're going to be talking about today. The seminar that's coming up is going to go into more detail into more complex systems like the VAV systems and the other systems that you might find in a bigger facility. Much like the lighting, HVAC can benefit from having a maintenance plan. And one of the key things you can do to tune up your facility is to make sure that your temperature set points are effectively meeting your needs. And that is that the temperature set points are at the right level and the systems are then being shut off when the facility is unoccupied. And so regularly check the thermostats. Most of you, if you have a thermostat, it's going to be a programmable one. If you've got an older style, non-programmable, the round dial, I would encourage you to change it out to a programmable system. You do have to be a little bit careful to make sure that you find a thermostat that can work with the equipment that you have in operation, but the packaging and the specifications for the thermostats are pretty good at telling you what type of thermostat works well for what piece of equipment. So program it, and don't just program it and forget it. You want to program it and periodically check it, because I don't know about you, I hear tons of complaints about building operators who struggle with the building occupants modifying the set points and changing the hours of operation. And so like I said, just follow up and find a spot that you want your temperatures set to and nail down the hours of operation that you want to have, and then check it. Because if you can reduce your heating energy set point, your heating temperature set point by 1 degree, Energy Star suggests that you can save up to 3% on your heating energy costs and heating energy consumption. Conversely, on the cooling side, if you can raise your cooling temperature set point, so in this case we're showing a temperature of 72. If you can change it to 73, you can save about 1% on your cooling energy consumption. And that, I haven't found any supporting data for that. That's more of my engineering judgment at this point. But then on top of the thermostat, you also want to make sure that you're changing filters. And a dirty filter is not necessarily going to make you consume more energy. It may be affecting the life and operation of your HVAC system, though. If you've got a dirty filter, it's not going to, the fan's not typically going to put out as much air as it would be able to with a clean filter, and then therefore maybe you're going to be running your HVAC system longer, or people are going to find other ways to modify the operation to improve their comfort if they're not comfortable. And then clean equipment per manufacturer's recommendation. You know, this picture here is of a condensing unit, and you have a unit like this on any split system, whether it be a heat pump or a air conditioning system. And this is where the heat gets rejected from your building. If you're in a cooling mode, the refrigerant gets evaporated inside, it gets condensed outside, and this is where the refrigerant is condensed and the heat is rejected. And so if you've got a dirty set of fins here, or if airflow is not flowing optimally through this, you're not going to have as much heat rejection, your compressor is going to work harder. And so I've had customers tell me that they come out here periodically, depending on where these are located, and they'll take a soft bristled brush and make sure there's no moss growing on the fins, and they'll pop the top off here. Of course, you got to make sure that you're again following manufacturer's recommendations, because there are some safety issues and there's some delicate equipment here that you got to be careful with how you're handling it. But you don't want leaves, for example, inside here fouling up again the potential heat rejection. You want to optimize the heat rejection here at this site. And with that, I'm going to talk about some other resources that are out there. We've got a commissioning guidebook that's produced by FEMP, the Federal Energy Management Program. I found that useful. And we've got a retro commissioning handbook that was published by the state of Oregon. And then finally, we've got a practical guide for commissioning, which is published by PECI. Some of these documents are a little bit old. Let's see, this one's 1999. Even though they're old, the concepts are still adequate. They can give you some tips not only for commissioning but also for tune-up. The idea that you can optimize your your replacement of fixtures and HVAC set points. All those pieces of information are provided in greater detail in these books and other books as well. But at the close of this webinar, we'll be emailing out, or at least later on today or tomorrow, we'll be emailing out links to these documents and some of the other benchmarking resources that we highlighted before. So as we draw to a close here, I want to highlight the fact that you have the ability to get a free energy consultation. PGE and Energy Trust provide energy efficiency consultations to assist businesses and help them identify energy efficiency opportunities, and then capitalize on those with some very attractive incentives that are available from the Energy Trust of Oregon. If you are a commercial customer, you'll want to either go to our website or talk to Paula Conway, and her number and email are there on the sheet. If you're an industrial customer, you can talk to John Maloney, or you can go to the website. And the Energy Trust website has some information as well. Thank you very much, and with that, I'd like to hand it off to Lorena.
Thank you, Greg. And again, as Greg mentioned, early next week we'll send out the recording of the webinar and then also the PDF of the materials along with the additional handout with the links that you can visit for more information. And we also want to share upcoming webinars if you want to join us for those. Many of you register through our website, also give us any feedback. or join us for any of the other ones. We have a polling that came up on the right side of your screen. If you wouldn't mind taking a few minutes just to fill those out, give us some feedback about the webinar, and we're always looking for opportunities on how to improve. And lastly, we also, if you have more questions, feel free to submit them. I have a couple, Greg, that came through, and then if any other ones come through, I will address them. But the first one is, when you have different types of buildings, that have different meters, what do you recommend, or where should they start as far as benchmarking?
Yeah, that's a good question. I think one of the key things is identifying where your meters are and what equipment those meters serve. For example, in PGE territory, you can get 3 bills, but 2 of your bills may be for exterior lighting that really isn't metered, and that use isn't going to change over the course of the year. It's billed out at a set rate, and that billing is not going to change. So if you've got multiple meters, make sure that they are serving loads within your building that you can then discern where that power is going to. That's an opportunity to kind of reduce your workload. So moving on from that, we deal with a lot of facilities that do have multiple meters, and so then do your benchmarking and figure out which meter has the most use, for example. Maybe you want to concentrate your effort on the largest energy consumer. If you're an operator of a large office building, for example, you may have a house meter that is providing energy to the core lighting and maybe the lobby space, but that energy consumption is going to be nothing compared to the occupied areas of the office. So start off with, what meters can I affect, and then move on to what are the biggest energy consumers that I'm dealing with.
Thanks, Craig. And then the last question was, for example, when you're talking to customers, what are the first 3 things you would recommend that they start with as far as commissioning or building tune-up?
Yeah, definitely start with the benchmarking, because if you don't know where you are, you can't determine what your next best step is. If you're a 2,000 square foot office building and you benchmark yourself and you're way off the chart, you're way high in your energy consumption, you're probably not going to want to have a third-party commissioning agent come in and commission your building. But with that high energy consumption, you really do want to take a close look at what type of building tune-ups can you perform. And then if we do increase the scale to that larger type office building, if you're consuming 16 kilowatt hours per square foot per year and you're in natural gas, you have natural gas heating, it again may not make sense for you to hire a consultant to do a full-blown commissioning, but maybe you do want to hire a consultant to come in and look at your HVAC systems or look at your lighting systems, or maybe you want to, instead of putting energy and money and time into commissioning, maybe you want to talk about what sort of energy efficiency improvements should you make, and those types of questions, those energy efficiency and incentive opportunity questions, are best answered by folks who are dealing with the programs, the Energy Trust of Oregon and programs, and so that would be your utility, your Energy Trust contacts that we've provided to you. So feel free to ask us questions if you've got more questions about how to move forward with either commissioning or energy efficiency opportunities.
Great. Thank you, Greg. And thank you again, everybody, for joining us. That was the last question.